Good morning, ladies and gentlemen. Thank you for joining us for the Bank of Baroda Hackathon webinar on generative AI. Today we have with us Mr. Hiren Kodiar, Technology Strategist at Microsoft. Hiren is going to take us through generative AI, a session on generative AI, tell us how Gen AI is going to revolutionize the banking industry, how are the use cases, what is it going to change, how is it going to work in the banking industry. And then we will progress our discussion towards our hackathon, which is upcoming. This hackathon is hosted by Bank of Baroda. It is in collaboration with Microsoft and in partnership with Ideate Next. Right. So we'll quickly get started. So without much ado, Hiren, over to you.
Hi everyone. I believe I can you can hear me and also see the screen that I'm sharing. Um, just give me one moment and I'll get the conversation going just to check.
We can hear you,
Stanford, just
Hiren.
give me a go ahead if I'm audible and visible.
Yes, audible, visible, and screen share is also on.
Perfect, perfect. So I think in that case, let me get started. So hey everyone, as Stanford rightfully introduced me, this is Hiren Kodiar. I work at Microsoft as a technology strategist, focusing on banking and financial services industry, and typically manage customers such as Bank of Baroda and so on. So firstly, thank you for showing a lot of interest in participating in this hackathon. It's a great initiative by the bank. Adopting a technology as new and exciting as generative AI into the banking use cases. So, the purpose of today's conversation is going to be discussing a service called as Azure OpenAI. I'm sure you have had a look at it already. If not, I'll give a very brief idea on what it is, just to set the context, and then we'll dive a bit deeper into how it is revolutionizing several use cases and implementations that we see across this segment and multiple other segments. Um, so, without much ado, I will dive deeper into our primary offering, as in Microsoft's primary offering, into the generative AI space with the frontier models, as we call as Azure OpenAI. So, without much ado, just moving on. I'm sure in the previous sessions, you must have had an overview of how the journey of AI has been, how we have come to an era of generative AI now. So I'll spare a lot of details that go deep into the foundational logic or the context of the technology and come to the use cases very fast. So just to give a quick brief, back in the 50s, we started with AI, then came machine learning, which then evolved into deep learning, which is where we were dabbling into use cases. Fairly good neural networks came there, which then led to this era of generative AI, large language models coming in, auditory, and now multimodal, right? So you'll see in the left side how typically the subset and the family of technology takes place. Generative AI is a part of deep learning, part of machine learning, and artificial intelligence as an overall offering. What you see here is a look at the overall portfolio of AI services on Azure. You'll see the whole AI infrastructure at the back, at the very bottom, powering the whole infrastructure. And if you or any of you managed to attend the Build conference that recently concluded, and what I'll do is I'll also share a link of that conference with the team here to share it with you. And some really exciting workload sitting there. Some of the sessions went very deep into what it takes for Microsoft and Azure to power the generative AI revolution, power OpenAI, powered models as powerful as ChatGPT, GPT-4o, and so on and so forth. What's the sort of infrastructure that goes into it? Now that we have that infrastructure, those sort of literally virtual machine, GPU level virtual machines available, What sits on top of that are a bunch of models, right, that can be used. When it comes to generative AI, the top of mind recall is typically models like ChatGPT, which is an implementation of GPT. Initially, it used to be GPT 3.5, then 3.5 Turbo, 4 Turbo, and now we have 4.0, which is a Omni, a multi-model capability. Along with these models, there are several other models that are available on Azure. There is a model called Florence for visual analysis, Turing, Whisper for voice based analysis, embeddings for vectorizing content and so on, DALI for image generation, and so on. There are also models that are available in the open source, like Meta's Llama 2, and Mistral, and so on and so forth. The whole library of transformer models that are available in Hugging Face can also be provisioned via services like Model as a Platform, Model as a Service. They are all hosted into a technology known as or a service known as Model Catalog, which is where you can actually construct some really complicated and sophisticated pipelines of AI inferencing. These models, they can not just be hosted onto a model catalog. You can also see their relative performance. You can perform some auto ML capabilities and do some comparative analysis on which one fits at what activity, which one might do a good sentiment analytics versus which one can be good for entity extraction versus intent recognition, and so on and so forth. You can also measure things like MLOps and LLMOps, where you can actually measure a drift on data and inferencing over a period of time, and then figure out how they are trending, or how they're tracking rather, across the duration of your implementation. So in short, what I've done is I've said that we have moved on from model implementations to actually Azure machine learning as a service, right? Now, these all are going to be really relevant for our customers when the use cases move from a proof of concept stage to an actually production implementation and BAU, or the build to run phase. That's when they want that's where a huge amount of traffic really comes onto these models, and the inferencing has to scale up to the amount of traffic or the amount of accuracy and so on. So how to do that beyond a proof of concept is something where these services come into the picture. And then on top of that, we have several Azure AI services which can be which sort of enriches this use case. So the primary one of that is the Azure AI OpenAI service. We'll go slightly deeper into this today. The OpenAI service, I'm sure some of you must have had a hands-on experience on that already. We also have a playground on the portal where you can try things out. And that's where all those exciting models from OpenAI, which are GPT-4o, DALI, so on and so forth, are actually available as deployments. You can actually instantiate them, play around with them, or think of constructing a solution around them. Supporting these models, because these models are good at what they do in terms of inferencing, but then what do you really need with them is the strong backing of architecture which leads to results, right? So things like AI search, which generates those vectors and arranges your data for inferencing. So for example, not all models of this capacity are expected to be fine tuned, right? I'll come to that topic later. So AI search is something that helps you with RAG, retrieval augmented generation. AI speech is a service that helps you, add a voice mode to your AI integration. So, very exciting feature nowadays. If you're using the production version of ChatGPT and so on, you would be so used to interacting via voice and not typing, and it takes away the drudgery of typing, and it just brings in a very natural conversation mode to it. So, AI speech service is something that helps you there. Vision is something that helps see helps the model see. There will be use cases where you may want to upload some forms that are pre-filled or some handwritten documents and run some sort of an OCR activity. That's where the vision models come in. Or several other things, like for example, you can click a picture of several branches in a city from the outside and figure out whether the branding of the bank looks good, or how is they different from the branding guidelines. So that's where the power of vision model comes in. um, Along with all of these, what really helps implementation on Azure is things like content safety. um, um, you know a large amount of implementation concerns that corporates, and especially in the area of highly compliant and regulated industries like banking, comes in is what is happening with my data. Whether that model is bound to behave a bit odd or give some responses which may be concerning. That's where your control over safety of content, what content is actually getting fed to the model, how the retrieval augmented generation is working, and the quality of responses. How do you measure it? How do you control it? That's where the AI content safety comes in. Document intelligence is a very interesting feature. We'll not dive very deep into it, but what it is used for is if you have a ton of documents which are structured in a way, maybe PDFs or Word documents and so on and so forth, which has pre-filled forms or receipts and so on. How does an AI model understand that content? How does it understand what is at the intersection of a row and a column? How do you interpret those data? That's where document intelligence helps us to extract the right content from the document and place it in the certain way where AI search can make logical sense of it, which can be pulled back. Language and translator services fairly self-explanatory in terms of what their purpose is. You must have seen some cool demos done at the launch of GPT 4.0. The model by itself does a lot of has a lot of multilingual and translation capabilities, but then what we used to do is we used to put a translator service in the front of the model for GPT 4 3.5 and 4, so that if you decide that a certain kind of users would speak Hindi or Bengali or Gujarati and so forth, and the model is expected to, or rather this translator would convert it into English, can be converted into prompt tokens, can be queried the model, and so on, right? And the responses can be converted back to the language of the user. So those are some of the services that are available, and all of these services, the machine learning services, these models, AI service, the advanced AI services, and the accessibility to the infra, all of this comes together in an offering known as Azure AI Studio, which is typically the sort of a workbench or a platform that can be used to keep all of these in tune and working. So this is sort of a high level overview of what all can be done on Azure when it comes to AI services. Um, Again, this must have reached you in the past, but it is very important from a Microsoft perspective to also assure our customers on what happens with their data. So the data that is used in these sort of inferencing, which can be in the form of inputs of tokens via prompts or completions or outputs, right, that come out. Even the data that is used for RAG, that is embeddings and training data, what happens to it? It's important for the customers to know that their data is obviously respected and available within their subscription boundaries. They are not shared with other customers in any shape or form. Their data is not shared back to services like OpenAI and any other modeling platform that is used, because the model is actually available to the customer and not the data back to the model. So the instance of the model, it brings comes to the customer. So the data doesn't flow out, right? The data is again not used to improve the performance of OpenAI models, right? The weights and biases of the model, as we call them, the parameters, are not something that gets tuned based on the nature of the model, based on the nature of the data. Never used on Microsoft third party or any other services. It is not used to improve OpenAI models in terms of accuracy and so on. These models are stateless. It's important to quote that. Data is only available to the model at the time of inferencing and then taken off. It's not actually gets stored anywhere or referred back. The fine tuning or the weights and biases that if a customer chooses to actually do fine tuning for a model for a very specific use case, again, is only available in the customer's exclusive use. It's never shared to anyone. So a very important point to be referred. I'll skip through a lot of slides here because I'm sure in the previous sessions they must have gone through, and may not be absolutely apt for this conversation. Um, this is an interesting uh, slide, or an interesting uh, way to look at the Copilot stack. While we use the word Copilot, it does not necessarily means the several Copilot offering that Microsoft has already embedded into our services, like the Microsoft 365 Copilot, Power BI Copilot, GitHub Copilot, and so on. This stack is used by enthusiastic developers and teams and service providers like yourselves, along with our customers, to actually build their own copilots using generative AI. And what is the ideal? What are the sort of building blocks of trying to build that copilot? So then there are, the Azure availability to Azure infrastructure that's available via AI Studio, availability of foundation models, models like GPT 4.0, Llama, Mistral, so and so. So availability of those models, they sit at the very base, at the very core of the offering. On top of that, what happens? On top of that, something happens which is known as AI orchestration. This is where the real work comes in for people who actually develop and are looking to develop use cases on AI. So, what sort of activity happens in orchestration? It is not just the fact that you are going to send a request to the model and the model is going to give out a response, and that's just going to work, because it's not as straightforward and easy as that. But then what can be done? Maybe the customer has a requirement of constructing the prompt in a certain way. They want the model to behave like an IT assistant, or maybe an expert, infrastructure support agent, or a loans expert, or an underwriting SME, or so on, right? So the behavior of the model is going to be defined by the meta prompt, and that behavior might change for the same use case. Also, it might change based on the persona of the user that's going to use it. So the meta prompt and the engineering of allocating the right meta prompt at the right time becomes really important. How does that meta prompt get constructed? That's There are technologies like prompt flow, model evaluation, and several other technologies like intent recognition, and so on. Now, there are several AI orchestration platforms or engines or services that are available. You must have heard the names of a few. Semantic kernel is one, LangChain is another. Prompt Flow from Microsoft Azure is such a service which allows you to visually arrange several stages or actions to move across, and coming to a perfect meta prompt. So a lot of activity goes into constructing the right meta prompt at the beginning, which goes along with the user query. The other two examples are really important: data grounding and plugin execution. Data grounding, a very important topic, especially areas which are regulated, compliant, and so on. It becomes all the more important, because when they are putting a service out to the world, they would want that service to restrict their knowledge to a certain specific data. You may not want a banking assistant to dabble into political conversations or conversations around the entertainment industry, for example. You may want a banking assistant, bot, or a banking assistant service to specifically limit their conversation to, say, a certain company. If Bank of Baroda is such a company, then you would want the bot to be only responding to data which is available within the Bank of Baroda, and also within that, whatever data is chosen to be made available to the bot, not all the data. So that all those technologies on the way that we limit, or the way that we scope the allowable data that can be used by model is called as data grounding, and we'll look at some of the ways to do that. Plugin execution is something interesting. So, for example, in a area where you may want some activities to be taken place in a sequential or a parallel manner. So, for example, I may say that, hey, what is the current NAV of an XYZ plan? for mutual funds. And along with that, by the way, my age is so and so, and I have so and so family members, and what might be the good plan for me. And if I give this entire thing as one single prompt, the prompt flow and the orchestrator engine and the intent recognition engine would try to break down my prompt into saying that, okay, the user is expecting the current NAV of a certain plan. Along with that, they have given some of their metadata for which they want recommendation on what plan they should go for. Similarly for life insurance, similarly for say home loan, and so on and so forth, right? Similar examples can be said there. What plugins would do is the orchestration engine would figure out that, okay, the NAV information needs to be fetched from a certain source. The product recommendation engine should source from a certain source, and if the user has also requested for the right branch to go to, that data might be sitting somewhere else. So there might be three plugins that will be invoked by the orchestration engine, each of them giving that data, and then the model eventually composing a final response which is then presented to the user. So there might be multiple plugins that can come into the use. There is also a lot of implementations where several of our partners are actually building specific plugins for their services, right? So all of this comes into the AI orchestration engine, which is then presented via apps. It can be sitting into a website, maybe an intranet portal for internal facing use cases, or a public website if it's a public facing bot or a customer service bot. And so all of these can be called as, co-pilots or assistants or bots and so on and so forth, depends on the language of choice. So together, the apps layer, which goes on to the orchestration engine to construct the right prompt, to query in the right grounded data with the right plugins called in, which then goes into the model for evaluation and to construct a very generative response backed by the GPU, the powerful AI infrastructure, and then all the way back to the end user. This is typically how the technology stack is built. And on top of all of this, we need to make sure that the content safety filter or the responsible AI metrics are measured, are captured, and are applied seamlessly. So when all of this starts working together at a scale, that's when you have the implementation ability, or the ability of taking the use case to production, right? Um, I will just quickly go through here. I mean, these are some kind of examples where use cases are prepared. One of the use case that I wanted to just quickly talk about is a contact center analytics, which means that the call centers that people call on to reset their password, register complaints, and so on and so forth. How does a company pull out analytics on top of that? So a call center agent, a caller is calling to an agent, and then there is a telephony server that sits in between and manages the conversation. The telephony server records the audio, of the, and you may see several calls where people are saying that this call may be recorded for quality purposes and so on. This is exactly what must be happening in the backend, where the audio files are recorded here. A speech to text service transcribes the data, and then that transcription of the data is interpreted by the service to create summarization, to arrive at the key topics, to arrive at the sentiment analytics score, several reasons to analyze this call. What that does is it gives and when you summarize across multiple such calls happening at scale, you tend to see a pattern as a customer on analyzing that, okay, a certain kind of messaging is probably not working well, or a certain kinds of messaging is getting a lot of good response, or there were so many missed opportunities to place a product versus the other. So all of this data then can flow into several real-time dashboards. Near real-time dashboards can look at data from the CRM or feed back into the CRM systems and so on. So there is one such use case for contact center analysis. The other very common use case is document processing and summarization. So a bunch of documents could be in the form, any form rather, and these documents, and typically these use cases are internal facing, where If we are talking in context of a bank, there might be several documents which are policy documents, which may be circular documents, and so on and so forth. Which has several versions. A new version of a certain document comes out, and so on. So you may need to process those documents to document intelligence, which can extract the metadata of the document. It's not just the content of the document. You may need to understand that this is regarding a certain policy, and this is so much version of the policy, this is latest or not latest, and who was the publisher, what date was it published, so on and so forth. Beyond content, right? And even the content is pulled out and then used by AI search. It used to be called cognitive search, but now it's AI search for for vectorizing that data. Once it is vectorized into a document store, Cosmos DB is used here for the vector data store. It can be the AI search itself or any of the vector DB you may choose for, which then becomes available to a web application and analytics via consuming an OpenAI service, which can do summarization, search, lookup, so on and so forth, right? Um, Enterprise Q&A bot, exactly. This is what we went through. I'll not repeat myself. Um, this one is another such implementation where multiple technical data and voluminous data is first pre-processed, maybe via something like an Azure Data Factory, which is kind of ETL ELT engine. I mean, these are various versions of how to prepare your data and store it into some sort of a database, which can then be pulled by several other engines based on the need of the data and can be put into a virtual assistant using translator and so on and served back. So there are several ways that an architecture can be constructed. And what I'm going to do next is I will take you to resources available on the Microsoft sites, which can give you some guidance on how such an architecture is constructed and how do you go about constructing it for the areas that you may want to build your solution on. You will get several such architectures and along with detailed write-ups of each of these areas into what I'm going to share next. Just quickly talking about document embedding and translation. If you're aware of how AI works and how generative AI works, embedding is a very important activity. What do we call with what do we need embedding for is actually to vectorize data. If you understand, generative AI models work on tokens. Tokens are nothing but vector representation of your data. So something that is spoken in a plain natural language, English, Hindi, multilingual, is converted into numerical vector representation of that data. And then cosine technologies like cosine similarity, semantic ranking, and so on is used to pull the right relevant data. So embedding, translation is optional here, but embedding is something that is absolutely at the core of how these transformer models work. So basically, there must be a huge library of documents. It can be a bunch of websites if you're scanning through a website, for example, which are then pulled into an intelligent document recognition engine, something like a document engine that Microsoft has. And then the data is chunked, right? It is pulled into logical segments, and there are several ways of chunking the data so that the right kind of data stay together in terms of completeness of an answer. Again, as I said, this is optional where you perform translation. You may not need to always perform translation unless the data is sitting in a language that is not that is not exactly the way that we expect the output to come in. This translated data, again, ADA 0.2 0.2 used to be the model for embedding for us. Now there are advanced models available, further versions of ADA itself. So the translator service is then used to make the data available into a readable form for the AI service. This is then further embedded and put into a vector database. And then again, the OpenAI service is then able to query it via cosine similarities and so on, right? The translator can be used here again to perform natural language processing. Person asking in their natural language, translated back to English, looked up the data, and so on and so forth, right? Um, so I think that I will. That brings me to an interesting topic. I think just for 2 minutes I'll cover this. How do you bring your knowledge to the large language model? The model GPT-4 would be available and it's trained on open internet for a certain cutoff date, right? And that date keeps moving based on the versions of the model coming in. But then, how do you bring your data as a customer to the model? So there are various ways of doing it. You can either put that data in the prompt itself, right, as a meta prompt or an in context learning. So your prompt itself is quite rich in the data that you want to supply. So the request of your prompt that goes into the model API itself has the data which you want to pull the output from, right? That is one. The other option is that you actually go through fine tuning the model. Now, fine tuning the model, for those who understand machine learning and deep learning and so on, would understand that fine tuning is a sizable activity. Fine tuning means actually changing the weights and balance biases rather of all the various layers of the deep learning model, which can be costly because you are then changing those weights and biases. But along with that, you're also creating a very unique instance of a model applicable to you. So that model then needs to be hosted onto a dedicated infrastructure. So the hosting charges comes in, and then on top of that, you query it. So it's something that you should, or customers should look at fine tuning only as a activity which is really important to do, and can't be done by either prompt engineering or retrieval augmentation. So fine tuning is available, but it's something that we caution our customers against. It should not be the first way of looking at it, because it can get out of hand in terms of both cost and trying to manage the weights and biases. And then the most commonly used way is retrieval augmented generation, RAG. That's where your data source is kept somewhere and prepared via vectorization, and is retrieved based on the query via several semantic lookups. This is the most common way that we see our customers using. So RAG models, something that we discussed in the previous slides, is also the best way of moving forward. I will just have a rather than going into further topics, I can just look at the time at hand. I believe I have somewhere around 5 more minutes. I might as well go to some of the resources that can be used by the team here. Right. So I'll show a few of the areas that you can get much more details on what I'm saying. One such area is the Azure Architecture Center, right? Once you go here, you can just search for Microsoft Azure Architecture Center. Once you open this site, there are several places that you can actually search for. So you can just come here and browse architectures, and over here you would find architectures ranging across all of Microsoft services. What you can do is you can search for OpenAI, and you will see a bunch of architectures that you can use in your implementation of the use cases that you picked up, right, for the hackathon. So firstly, just quickly going on to the hackathon page here, you will see several challenges that are available to you, right? Customer service, we saw one such example of a customer service analysis, right? Then there is also risk management. So how do you cater to the needs of, how do you understand, say, credit risk for a housing loan use case? A certain kind of a user comes in requesting for a housing loan. If that person who is an applicant is a recent person in the job scene, right? They've not built up their credit score enough. So how would you analyze their various parameters to say the fitment of awarding the loan or not? So risk management, for example, is one. So identify potential risk anomalies. If some of the data is not matching in their application, how do you do that, right? Audit and compliance, how to audit the financial transaction, detect non-compliance issues. So I think a lot of this comes from knowledge that's already sitting in the database. and then evaluating the data that has recently come in, and then come up with generating audit reports based on the data that's available. You will find a lot of these implementation use cases available. Operational efficiency is how do you automate tasks. Advisory is how to offer real-time advice based on the data and trends. So this is a sensitive use case, because based on this the end customers might end up taking decisions. So how do you so the data grounding rules really come into picture hard over here. Personalized content generation, hyper parameters, hyper personalization. So I mean, one of our customers that used the hyper personalization very interestingly is exactly this, generating personalized marketing materials. So they used our DALI 3 model based on the persona of the user. So for example, let's say you have a bunch of users. Let's say, just for this hypothetical use case, you have 100 users whom you are considering as a potential for housing loan, for example, or home loan, right? How do you do an outreach to them which is a bit more personal? When you say a bit more personal, each of those 100 users might be of a different age range, might be belonging to a certain region within the country. If we are just looking at India, some of them might be in the south of India, some might be in the west, north, and so on. So different age range, different regions, um, um, different income brackets, and so on. And based on those metadata parameters for each of those 100 customers, you can create specific prompts using that AI orchestration and prompt flow and so on, semantic kernel and so on, to create a prompt which is very specific to each of those 100 users, and then query a model like DALI 3 to generate an image, uh, let's say maybe showing a house relevant to that region. If it's a mega city, then you show a building apartment. But if it's a slightly area where it's an open area, you can show a house, and so on, right? And build up a persona of a person who resembles the person's metadata, and how what kind of an impact that sort of a hyper personalized use case can have. So I think several such challenges are there, and these architectures are something that will help you meet those challenges. So here is search and query for employee for the knowledge base, right? This is for the internal optimization use case, for example. You will see this use case is about logging and monitoring. So this is actually more in terms of the backend implementation. How do you make sure that the model remains measurable and scalable? This is how to use a gateway in front of OpenAI deployment. So gateway is exactly used for gating criteria, in the sense that if a certain load balancing, if a certain endpoint is under tremendous stress, the user should not face that amount of delay. The application should be smart enough to understand and identify the traffic routing and route it to an appropriate model. Here you can also apply a level of intent recognition if that's an interest. Based on several parameters, you can define which endpoint to redirect the request to. This is an end-to-end chat reference architecture. This is very detailed in terms of how you can go about setting up. So I'll probably just quickly open this and show you. Um, do I have Tally implementation? I'm just checking. No, so I think I'll stick for that. Yeah, so if you'll see the baseline end-to-end chat reference architecture, I'm just telling you how do you go about looking at it. This write-up would be in detail explaining how does a end-to-end chat reference architecture become production ready. You can see there are several elements involved. There is a firewall that comes in, then there is a app service endpoint that gets, so depending on several parameters, you may define which endpoint it should go to, right? Then there are secrets and passwords and passkeys and what all that are managed in the key vault. It then gets sent to several endpoints, which are then reached out to a machine learning endpoint, and that uses OpenAI service. So this is one such area where you can look at implementation guidance. Maybe not necessarily at the POC stage or the stage at which you are in. For that, you can look at much simpler implementation structures that we had seen above. But then as the use case gets closer to production, how each of these areas will help you. So this is a great read. And the recently concluded Microsoft Build event had a dedicated 1.5 hour session just going deep into each of these areas by our product teams, and explaining each of these areas to you. So I think definitely something I would recommend to have everyone to read through as one of a few of these architectures, right? um, and then finally, before I just stop, this is how the OpenAI playground looks like. I'm sure some of you would have experienced it. I'm just testing it with GPT-4o here. So if I just say hi here, I'm hoping it's warm enough. Yeah, it can say. So here I'm just typing, hey, give me the list of credit cards. So this is quite an open-ended question. I've just put in, give me the list of credit cards, and what it does is it gives me a generic list. There are many types of credit cards available, right? And it gives me the whole list of sort of credit cards uh, that are made available. I'm sorry for, yeah, okay. It gives me the whole list of credit cards that are available here, and then it also mentions some of the popular credit cards available. Now, what I'm going to do here is I'm going to give the meta prompt here. I'm going to say that you are a friendly banking virtual assistant for Bank of Baroda, and you source all your um, information strictly from their website at baroda.in. Yeah. And that's it. I'm not going to apply, I'm just applying these changes, and I'll restart the session. And now, if I'm saying, now it should ideally, yeah, this is, basics of grounding. What I did here is I just gave the fact that they should not go anywhere else. And now it has started giving me specifically details from Bank of Baroda website, and then, with references to their code. So here, what I can do further is I can also add some of the data. I mean, uh, I'll see if I have a service already, but I'm not. So I think I can actually add some of the PDFs that are publicly available on their website, and start, like, for example, an annual report and so on and so forth. I can upload it here, and then what will happen is, once the data is available here, the further grounding will happen, where along with the system message, it will also limit the responses to this data and start giving me answers especially from this data only. So there are several ways that I can actually train my model, or tune it and ground it to give me specific responses. Now from here, I can actually go ahead and deploy it to a web application, which will create a website out of it, and show me the results here. So several ways that these can be done. I'll also just try one more sample here, where if I upload an image, right, this is showing you the power of GPT-4 Omni, and I'm just saying, what do you see here as a sample? Now all I'm supplied is a Bank of Baroda image to it, and yeah, so I think it's then further going to, yeah, it is going to do all that analysis for you. And maybe it ignored one person standing at the stairs on the shade, but can clearly identify three people, and so on and so forth. So I think multiple things can be done as an implementation. So with that, I would, just sensitive of time, Stanford, if you are there, we can actually conclude the session at this point, and see if there are any queries that you may want me to pick up.
Uh, Perfect. Yes, Hiren. So Hiren, as of now, I don't see any queries that have come in, and firstly, I'd like to thank you for this webinar and for giving us your time on this one. If there are any questions, and if there is a need, I will get in touch with you and we can route the questions to you.
Sure, it was a pleasure. I'm sure, having just 1 hour to show the depths of these technologies is difficult. What I would request Stanford and the team to do here is to also share a few links that I'll share with you, Stanford, on the recently concluded build event that will richly benefit the audience here, because those sessions are roughly an hour long each and go very deep into all of these use cases. So you'll be having a lot of technical reference on how to build your solution along with that architecture reference session.
Certainly, certainly, we'll do that. Share us the links, and we will update that on the website and on the YouTube link as well.
Okay.
Perfect. So, thank you so much again, ladies and gentlemen, for your time here. In case if there are any questions, please feel free to drop us your queries on our info email, and we'll be happy to address them from here. Thank you so much again. Thank you so much, Irene.
Thank you. It's a pleasure. Thank you.
You're welcome. Bye.